In this lesson, we're going to be talking about different types of cryptography. The first type of cryptography I'm going to talk about is symmetric cryptography. And by symmetric, I mean that the key is the same for encrypting or decrypting. So I use the same key whether I'm encrypting the data or decrypting the data. One of the things about symmetric key cryptography is that they use a shorter key length than for asymmetric, which I'll get into in a couple of minutes. It's also faster than asymmetric. You can use algorithms like DES or AES, those are both symmetric key cryptography algorithms. And you can use a utility like AES crypt. I've got a file here called text.txt. I can use AES crypt. I'm going to encrypt it with the password cookie. And now I've got text.txt.aes. And if I just take a look at that, it looks like garbage. Now to decrypt it, I just use AES crypt again, -d with a password of cookie, and text.txt.aes. And that just decrypts it. So that's how you would use symmetric key encryption to encrypt a file for this example. Symmetric key uses either stream or block ciphers, and the difference between stream or block ciphers is that block takes a block of bits at a time, and it's a fixed length block. So for example, 64 bits. If I were to use a block cipher with 64 bits, I would need to take in 64 bits before I could start encrypting. If I didn't have 64 bits to encrypt, I would have to fill it with padding in order to get up to the 64 bits. A stream cipher, on the other hand, will encrypt a bit at a time, so it doesn't matter how many bits you've got, you don't need to have some multiple of the block length in order to encrypt without padding. Another type of cryptography is asymmetric. Asymmetric, as you would expect, uses two different keys. That's where we have a public key and a private key. Asymmetric cryptography uses a longer key length. It also has more computation, and the encryption process is slower with asymmetric key encryption. One of the uses for asymmetric key is for signing documents or emails, for example, where I would have the private key sign something and the public key would be used to verify the signature. Another reason for using asymmetric key encryption is to ensure that who you got it from is who actually sent it. Since you've got two keys, you always know who the other end of the equation is, where with symmetric key, since it's just one key, if you can intercept the key, you can decrypt and also encrypt messages. And so if somebody can figure out the key, you can break into a communication stream using symmetric key encryption. So asymmetric gives you the advantage of ensuring that the other end is who the other end says they are, since they're the only ones who should have the private key in this particular instance. In practice, however, hybrid encryption models tend to be used. And that's where you would use asymmetric encryption to encrypt a symmetric session key. Since symmetric is the faster algorithm, if you're transmitting a lot of data, particularly in a real-time sort of fashion, like a web session, for example, you would want to be using symmetric key encryption, but you would want to make sure that you transmit the session key using asymmetric key encryption. Now, we can use asymmetric key encryption to encrypt a file. It's going to be a slower process. You probably want to use smaller files in order to do that. Fortunately, the file example that I have here is a small one. The thing about this, though, is I've got to generate a key in order to do that. So I'm going to generate a key here. This is going to be an RSA key, and I'm going to call it private.key, and my key length is going to be 4096 bits. And we're generating the RSA private key here. and now it's asking me for a passphrase. This simply protects the key. It has nothing to do with the keying material itself. It just protects the key so that nobody other than the person who knows the passphrase can make use of the key. Now I've got to generate a public key from that private key. I'm going to use OpenSSL again to do that, and it's asking me for my passphrase for the private key in order to access it. Now I can do the actual encryption, and I'm going to use OpenSSL again. Encrypt. I'm encrypting it with my public key so that it can be decrypted with the private key. So that's how I would do the encryption. Now to do the decryption, I see that I've got my encrypted text there, and I've got my encrypted text. So in order to decrypt it, I do the reverse process, where I'm going to decrypt. I hand it my private key, since that's the other side of the public key, and I'm going to feed it the encrypted text, and I'm asking for a file name of plaintext.txt out. It's asking me for the passphrase for my private key, since I have passphrase protected it. And now it should have the plain text back. It looks right. Let's just check. And there's no difference between the original text and the plain text that came out of the decryption. So that's just a little bit on the couple of different types of cryptography and different ways of thinking about cryptographic ciphers and how to use them.